Yeah, remind me to write up a little IT request to fix my reporting thing. All right, so we finished adding, subtracting polynomials with the patterns. So now we got to do power functions. Yeah, these kind of suck. These, especially composite functions. Ick. All right, so back in last semester, right? We did function notation a little bit, I think, where we had something like, I don't know, y equals mx plus b, right? That's a linear equation. And it's a linear equation. And function notation just meant that we used f of x instead of the y, right? And if we had a number for x, then we would substitute it in where the x was in the other expression. Okay, we're going to we're going to have two different functions here. Now, you could call this the f of x, the g of x, the h of x, all different kinds of names, right? J of x, I've seen, k of x. It doesn't necessarily have to be f of x because we're going to be dealing with more than one function. Okay, in this case, we have the f of x. And then we've got the g of x. So when we apply our mathematical operations, addition, subtraction, multiplication, and division, we create a new function, and we usually call that new function the h of x. Not all the time, though, so you got to kind of be careful. All right, so let's apply our mathematical operations to our two functions that we have. So we're going to take the f of x, which is 2x, good. So this equals 2x plus, and the g of x is 3x plus 1. Pretty easy, right? And we do have to simplify this. Two x plus 3x is, and then I have my 1. There's my answer. Yeah, now this is where I'm going to lose students say, oh, this stuff is easy. I'm going to go play my video games on my phone. It gets hard. I'll tell you right now, this is not easy stuff. It's going to get hard and complicated. Just hang in there with me. All right. The next mathematical operations, subtraction, multiplication, and division, I highly suggest using parentheses when you set these up. Because if you don't, chances are you'll get the wrong answer. Okay. So I'm going to take my f of x function, which is 2x, minus, and I'm going to use parentheses for the g of x, which is and why do I say you better use parentheses? Because you have to distribute the minus sign. So I have 2x minus 3x minus 1, which is
minus 1.
Oh. Should drink some more coffee. Okay. So addition, subtraction, not too bad. Subtraction, easy to make mistakes like I did. All right, then multiplication. So I have the f of x, which is, and then I'm going to use parentheses because I don't want to screw this up. G of x is, And I'm going to distribute 2x times 3x. 2x times 1. Sorry, I had to get some water. Thank you. Thank you. All right, division. The f of x is 2x divided by the g of x is, and why do I say to use parentheses here? What happens is students think they can cancel the 2x and the 3x. Like, they can cancel and make this a 1x and this a 1. You can't do that. Okay? That's why I highly suggest using parentheses. Remember, when you have two terms in the denominator and numerator, you have to lock them in there. All right? That's it. That's my answer.
Main restrictions?
Yeah. Let's talk about that. What can't I have in the denominator of a fraction? Denominator. I'll be back. Cannot equal 0. Cannot have a 0 in the denominator, right? So, we're going to have a restriction. Let's figure out what makes our denominator 0. So let's take our 3x plus 1 and set it equal to 0 and solve for x. Let's see, minus 1, minus 1. I get 3x equals negative 1. Divide by 3. Divide by 3. So x cannot equal negative 1/3. There's our domain restriction. Because if x did equal negative 1/3, it would make my denominator 0. Make sense? Now comes the really fun part. Oh, this I'm not kidding. This is the funner stuff. This is the funnest stuff. This is even funner than your video games that some of you are playing. All right, composite functions. Back in the Stone Age when I learned composite functions, we did this notation, okay? This was our notation. It was the f of g of x. And life was great because we would work from the inside out. And then one of you youngins along the way, the past few decades, use guys, the two Utes, they started using this crap. The f of open circle g of x. Okay? I don't know why the younger generation started using that. Because, the open circle here, the fog. I call them fog because that's what must have been in their brains. I still, to this day, I can barely teach this. It confuses me so bad. I don't get it either. So I'm always going to use this. When you take, some of you take, whatchamacallit, pre-calc next year, you may see this a lot. So if you're thinking of taking pre-calc, I'm going to check with the pre-calc teachers and see if they use the new fancy symbolization or not. I hate it. So I'm always going to use this one. Okay. So here's my f of x. This time it's 3x, right? And my g of x this time is 2x minus 1. What's the what? Huh? What? What? You're not talking to me? You're not talking math?
No.
Okay.
He is talking what are you talking about?
What are you talking about? Huh? What? What? What you talking about?
Huh?
Huh?
What?
What?
Who? Where?
I don't know. Okay, so I'm going to use the f of g of 2. I'm going to rewrite it this. The f of g of 2.
I was tweeting.
I like this symbolization better because I like to start from the inside and go out. So, we're going to do the g of 2 is the innermost one. We're going to do that one first. So the g of 2 is going to equal, I look at my g function. I have 2. Now I'm going to substitute in that 2 for x. So wherever I have an x, I'm going to put in parentheses minus 1. So I'm going to substitute in 2 for my x. So I have 4 minus 1. So my g of 2 equals 3. Pretty cool, huh? Now, I'm going to substitute in 3 for my g of 2. Isn't that cool? Yes. So I have my f of, I'm going to substitute in 3 for the g of 2. So the f of 3. And I'm going to go to my f function, which is 3 times x. This time I'm going to substitute in 3 for my x. And the f of 3, so 3 times 3 is 9. And I have everything solved for. That's my answer. Piece of cake, right? Try that with that stupid new symbolization from you guys, the 2 Utes. Let's see if this gets any. I think this actually gets more difficult. All right, I'm going to use the G, and I like to make my first parentheses bigger, right? G of f of 3. So the first thing I'm going to do is the innermost one first, which is the f of 3. In fact, we know what the f of 3 is. We did it up there, right? So the f of 3,
Equals 9.
yeah, it's going to equal 9, but I'm going to do the whole thing just for teaching purposes, right? Going to substitute in the 3 there. And we know that that equals 9. So then, I'm going to take that 9, substitute it in for the f of 3, right? So that gives me the g of 9. So I go back up here, grab my g function, 2 times x minus 1. I'm going to substitute in 9 for my x. Okay. So I have 18 minus 1, which is 17. Got all my substitutions in. It's my answer. Getting the hang of this yet?
No.
I think you have to pay attention and take notes to get it. Yeah, now you are. Okay, I'm going slow. Am I going too fast?
No.
You are kind of going fast.
Am I going fast?
You're not going too fast. I just 2 speeds at this
It is confusing. It is confusing. I don't think I'm going too fast.
Yeah, you were.
I didn't think so. I thought you were trying to pull one over on me again.
I was.
Okay, the f of negative 2. That's almost inappropriate. The f of f. Okay, so I do the innermost one first. So the f of negative 2. What color am I using? Blue. The f of negative 2. So I'm going to grab my f function, which is 3, and I'm going to substitute in for x, right? The negative 2. So the f of negative 2 equals negative 6, right? So I'm going to substitute that back in for the f of negative 2. And then I have to do the f this time, substituting in negative 6 for that. And my f function, 3 times x. This time for my substitution of x, I'm putting in negative 6. So we get negative 18. This is really a hard concept, and you're right, it's very confusing. Are you guys touching each other again like yesterday?
He was
Not found right. That sounded wrong.
Yeah, that did sound kind of.
Are you recording yourself?
Yes, I am.
Uh,
Are you talking about buildings?
But I like this class, so I'm gonna put this one up on
Oh, okay.
YouTube. Okay, turn the page, as Bob Seeger would say. So there's a couple of ways to do this. And last hour, I remembered the shortcut way, so we're going to do this the shortcut way. So we're going to take the two functions and multiply them together. Now, we could do it first, then substitute 5 back in there. That was the long way. The short way is we're going to go ahead and figure out what the f of 5 is and the g of 5, and then multiply them together. A lot shorter. So again, here's my f of x function. Here's my g of x function. This time they're giving us a number, so we have to evaluate it. If they don't give us a number, just leave it in x terms. We don't have to evaluate. This one we have to evaluate. They give us a number for x. Okay, so I have the f of 5. I'm going to plug in 5. So my x function is 3. Here's my x times x plus 2. For my x, I substitute in 5. So the f of 5 equals 15 plus 2, right?
right times that.
Which is 17. So there's my f of 5. Then I need the g of 5. So I'm going to grab my g of 5 here. And I have 5 times x minus 4. Going to substitute in 5 for my x this time. So I get 25 minus 4, which is 21. So now I got to multiply those together. So I'm going to take.
Oh, this makes sense now.
Yeah, it does. It's a lot easier doing it this way than the other
Why are we
way.
doing it the other way?
The other way takes a long time and it's confusing.
So why are we doing it that way?
We're not. We're doing it the short way.
I don't think so.
You take this?
Hmm?
You okay there?
Yes, I'm fine. Yeah, I'm just.
You just got tired.
I brought extra blood pressure medication today.
Uh,
Okay, 17 times 21. What do we get? Hey, put all your calculators back, by the way.
17.
357.
Ah.
So we're done. There's the shortcut way. You want to see the long way?
no, please, stay with the migraine.
Okay, number 2. We have f divided by g. This is going to be an easy one because we don't have to evaluate it. There's no number for x. So my f of x function, 3x plus 2. And because it's going to be in a fraction, I'm going to put it in parentheses. And my g function, 5x minus 4. Again, since it's in a fraction, put it on parentheses. These are not the same, so we're done. We cannot simplify those.
So basically, when we're dividing, it's basically just gonna be that. Like, it's just gonna stay the fraction.
If there's something you can cancel out, then we can simplify. But 90% of the time, you're not going to be able to. Oh, by the way, what do we need for number 2? Something. We need a domain restriction, right? Yeah, what can't we have in a fraction? Yeah, 5x minus 4 cannot equal 0. Okay? So let's find out what that is. Let's add 4. So I have 5x equal 4. Divide by 5. So our domain restriction here, x cannot equal 4/5. Okay? Don't forget when you divide, you need a domain restriction. Okay, so this time they did give us a number for x, so let's evaluate each one of these. Okay, we need to evaluate the f of 4. Now this is another reason why I hate those composite functions with the open circles. It confuses me with the multiplication dot. In my second hour, I did a composite function instead of multiplication. Bad. Okay, so I'm going to do the f of 4. So my f function is the absolute value of 2. I have an x. I'm going to substitute in minus 1. Substituting in 4 for my x. So this equals the absolute value of 8 minus 1. Absolute value of 7, which is just 7.
Do we have to have the lines?
What's that?
Do we have to have the lines?
No, well, technically, yeah. Certainly wouldn't take off for it. Then we have to do the g of 4, right? Bless you, man. Okay, g, let's see, I have a 5 times x
But it's
minus
not even
4.
hard, Thomas.
What?
Thomas said something.
He's been saying something all class period. So have you. You guys been annoying. Okay, 4 for my x. I have 20 minus 4, which is 16. Then I have to multiply them together, right? So 16 times 7 is 42 for 112. And then the last one. And I can hear you guys already crying because it's the last one.
We have to do this on the homework.
Yep, and you can do it on the Delta Math too. Delta Math.
Are you available on Facebook today?
You're a liar. Everybody does
I
Delta
will do
Math.
it.
Huh? Okay, start with the innermost. Composite function, the g of -2. So the g function is 5 times x minus 4. Going to substitute in -2 for my x. So I get -10 minus 4, which is -14. Well, no, because we're doing composite, so I have to go back and substitute in -14 for g of -2. Isn't this fun? Fun, till my daddy took the T-bird away. So I need to do the f of -14. So my f function is the absolute value of 2 times x minus 1. Substitute in -14 for my x. Boy, this is better than Call of Duty, man. Okay, 2 times -14, -28 minus 1. Good, -29. Absolute value of -29. 29. There you go. Nope, because the absolute value of -29 is positive 29. Piece of cake, right? You know, when you get bored at home now, you could re-watch the video of this, and instead of playing video games, I think it'd be kind of.
Thank you.
You're welcome. See how much entertainment I give you guys?
Right.
I'm going to stop this recording before I get myself into trouble.